in this lecture, we are going to discuss some of the disadvantages of semaphore, and we'll be seeing if we can address these problems and if they can be solved. So the main disadvantage of the semaphore definition is that we have discussed that it requires busy waiting. So what do we mean by busy waiting? So by busy waiting, what we mean is that while a process is in its critical section, any other process that tries to enter its critical section must loop continuously in the entry code. So in the previous lecture, when we have discussed about the definition of semaphores, we have seen how it works. We saw that there was a while loop, and then when a process tries to enter its critical section, if some other process is already executing its critical section, then that process will get stuck in its while loop until and unless the other process exits from its critical section. So we see that when one process is not able to enter its critical section, it is going to be stuck in the while loop. So it is going to loop continuously in the entry code and it will keep waiting there. So that is what we mean by busy waiting. Now, how is busy waiting a problem? So busy waiting is a problem because busy waits CPU cycles that some other process might be able to use productively. What happens is when a process is stuck in while loop, that means when it is looping continuously in the entry code, that process is still using the CPU even for it to work inside the while loop, to be looping inside that while loop. We need CPU for that. So it is just wasting the CPU. So if this is busy waiting was not there, then the wasted CPU could have been used by some other process for doing some other productive work. So that is a problem that we have with busy waiting. So this type of semaphore is also called a spin lock because the process spins while waiting for the lock. So it is very clear why it is called spin lock, because we saw that when a process is not able to enter its critical section, it gets looped inside the while loop, not able to come out, and hence it is called a spin lock because it is spinning while waiting for the lock. And the main problem with that is wasting our precious CPU cycles which would have been used by some other process productively. So this is the main disadvantage that we have with this semaphores because it involves busy waiting. Now the question is how that we can address that problem. Can we address the problem where the CPU cycles are wasted, that is involved in semaphore? So one way we can address it is that to overcome the need for busy waiting, we can modify the definition of the wait and signal semaphore operations. So by making some slight modifications to the wait and signal operations, we could get rid of this busy waiting problem. So this is wait and signal operations are involved in semaphores and we have already discussed. So the wait and signal operation means we have to modify the definition of wait and signal operations to overcome the need of busy waiting. So we know that when a process executes the wait operation and finds that the semaphore value is not positive, it must wait. So that is the definition of the wait operation that we have already discussed. So if the sum of 4 values positive when wait, that means it cannot continue, it will just get stuck in the while loop that is present in this wait operation. So how can we overcome the need for busy waiting here is a solution. However, rather than engaging in busy waiting, the process can block itself. So what does this mean? The block operation places a process into a waiting queue associated with the semaphore and the state of the process is switched to the waiting state. So what we mean by this is that when a process gets stuck in the wait operation, when it is going to get stuck in that while loop, instead of engaging in busy waiting, we will make that process to block itself. So when a process blocks itself, what will happen? It will stop getting stuck in the while loop, and instead of that, we will do is we will place that process into the queue known as the waiting queue, and then the state of the process is switched to the waiting state. So we will change the state of that process to a waiting state. So remember that is now no longer getting stuck in the loop, but instead of getting stuck in the loop, we are placing it into a waiting queue, and then we are changing the state of the process to a waiting state. So it can just be idle and wait for critical section to become free there. So it is not going to get stuck in the while loop and waste our CPU cycles for that while loop. Then after that, the control is transferred to the CPU scheduler, which selects another process to execute. So since it is not stuck in the while loop anymore. It is not going to use that CPU. So that CPU can be used by some other processes. So the control is transferred to the CPU scheduler, which will select another process to execute. So hence we are not going to waste a precious CPU by letting that process loop in that while loop and waste the CPU time. So this is how we can modify the definition of the wait and signal operations for the semaphores in order to avoid the busy wait.